Welcome to this video on setting up and running Makai's Automatic Route Generator, or ARG. We'll begin by creating a new project in MakaiPlan. For this example, we'll be working in the Hawaiian Islands region, keeping most settings at their defaults, except for loading in a custom cable type repository that already has our cable costs and installation speeds. Once the project loads, we'll navigate to our area of interest around the Hawaiian Islands. Next, we open the cable list to confirm that each cable type includes a cost and installation ship speed value. These two values are critical for the ARG as they directly impact how installation cost is calculated, including both cable procurement and expected installation speed. Next, we go to Manage Gridded Bathymetry under Bathymetry. We then browse for the gridded bathymetry file that corresponds to our area of interest. Makai accepts many different kinds of gridded bathymetry, but we primarily use data-driven geotiffs and Surfer 7 grid files. One thing to note is the ARG does not support contour bathymetry. Gridded data is required. After loading our bathymetry, we can then visualize it using rosters generated through MakaiPlan. In this demo, we'll generate a grayscale hillshade roster using our gridded bathymetry window. If you need gridded bathymetry data prior to obtaining higher resolution survey data, coarse bathymetry data for the whole world is available from download.gebco.net. Using the browser tool, you can select your region of interest using the map directly or by specifying the corner points. Afterwards, ensure the GeoTIFF grid format is selected and proceed to download the data from the basket. For larger areas, Gebco may email you a download link once the dataset is compiled, but for smaller datasets, it can be downloaded directly from the tool. Once downloaded, you can load the data into MakaiPlan as elevation-style gridded bathymetry. At this point, we can then load in any additional GIS data for visualization purposes. GIS data loaded into MakaiPlan is not automatically used by the ARG. You'll still need to import it separately into the ARG during rule creation, and vice versa. Data loaded into the ARG is not automatically loaded into MakaiPlan for visualization. With our supporting data now loaded in, we can create our seed paths. These define the start and end points of the route the ARG will generate. For trunk routes, at least 2 points are required, a start and an end. For branching network routes, only a single endpoint is needed, as the ARG will route them to the trunk automatically. In this example, we'll start by creating a trunk seed path from just south of Oahu to the northwest coast of Hawaii. We want to ensure that the points that we are creating for this example are not on land and have some positive depth to them. Next, we will create a branch endpoint off of Maui's north coast. For branching seed paths, we only need the singular point, so once we have added it, we can just end the path creation process. Next, we open the profile view of the seed path. From the Tools menu, choose Cable Type by Depth. This window allows you to assign cable types based on water depth, as well as to set a burial depth to trigger associated installation costs from plowing and burying the cable. Once we have finalized our depth values and associated cable types, we make sure to save these values, but we do not insert the cable types directly onto the seed path. Doing so would create additional route points that will constrain the ARG incorrectly. After finalizing our cable types by depth, we then move to opening the cost estimation tool, where we will add a new segment. Here we can define procurement costs, which pull values from our cable list that we defined earlier. We can also set associated costs for survey, shore-ins, installation for both plowing and laying sections, as well as costs for plowing, transit, and potential freighter usage. Makai provides default values based on industry experience, but we can also export or override our configuration into a file called costingdata.cstxml. The ARG will only recognize this default file name to pull the values from, so it's important to not save it to a new file name. With the initial MakaiPlan setup done, we can open the ARG window to begin route generation. The first thing that we do is we start by clicking Edit Routes and adding in the seed paths that we created. We need to ensure that we check the box next to the main trunk path so the ARG knows where branches should connect to. Every ARG run also requires a defined boundary and grid cell size. We will set this using Edit Boundary. There are multiple ways to create a boundary, including buffering around seed paths, drawing a polygon in Plan View, and importing a boundary from GIS data. For this demo, we'll start with a simple buffer and a large cell size to speed up calculations. At the bottom of the ARG window, we can check Display Boundary to visualize the boundary in the plan view. One of the most powerful features for defining a boundary is the Define on Plan View tool within the Edit Boundaries window. This lets you manually shape a custom boundary by adding and moving vertices. A well-optimized boundary helps the ARG focus on viable areas and avoids running out of memory. The software will warn you if your boundary and cell size generate too many cells. Before running a full route, we want to test the terrain rule only. So we click the Test button in the rule list to the right of the terrain rule. This quick validation ensures bathymetry is correctly loaded, seed points are valid, and the boundary and cell size are appropriate. In this case, the ARG generates a basic route successfully, limited only by the terrain rule, which prevents cable placement on land. After the test run, a results window appears showing whether the route was successful, how many cells violated each rule, simple diagnostics for troubleshooting some rule conflicts. For a better view of how the algorithm's logic works, we can check display cells and rerun the test. This visualizes how the ARG evaluates and selects routes. Now let's take a quick look at some of the ARG window components. Cable types and transitions are easily accessed via the buttons near the top. We originally set these in MakaiPlan, but they are also accessible through the ARG window. The middle panel of the ARG window governs our rule sets and rules. Rule sets define rules for different areas within the boundary. The default rule set covers the full boundary, excluding any special areas defined with edit areas. Each rule set automatically includes a risk-based terrain rule, which governs the allowable depths that the ARG operates in, a slope and side slope rule that defines a maximum slope value and a tolerance value. The max slope defines the desired slope limit the ARG should try to meet, while the tolerance sets an allowable range for the slope value that exceeds the maximum. We also have a maximum alter course rule, which limits the turning angles based on depth, and a minimum alter course distance rule, which controls the spacing between direction changes. Our distance-based tolerances should always be relative to our cell size, so we'll set ours here to 5,000. Next, we can enable these rules using their checkboxes to the left. Rule sets are also divided in between risk-based rules and cost-based rules. Under the Cost-Based Rules tab, we'll make sure that we have cable cost enabled, a cable transition cost enabled, installation cost enabled, and plowing cost enabled. These values will align with those set earlier in our cable list and our cable by transition at each depth, as well as those set in the cost estimation tool and saved to our CST XML file. We click Add Rule to include more routing constraints. Options include Avoidance Zone Rule, which avoids GIS-based features loaded from a shapefile. 100% risk forces the algorithm to be unable to go into the zone. A Crossing Rule, which enforces safe crossing angles over existing cables loaded from a shapefile. This rule can be disabled around seed path points to prevent failure in congested areas, and can be given an associated risk to discourage routes from crossing. A No Alter Course rule, which restricts route changes within a zone. A Proximity rule, which maintains a minimum distance or water depth multiplied distance from a GIS feature. If an algorithm option other than logistic curve is chosen, the generator route cannot pass over the GIS feature loaded in. We have a Costing Zone rule, which assigns extra cost per unit area within a GIS-defined zone. And finally, a Heat Map rule, which avoids or prefers areas based on values within a grayscale raster image or GeoTIFF dataset. We'll define the allowable range of values and determine the maximum risk to scale to. Higher values force the route around the given zone. For this example, we'll add a proximity rule around existing fiber optic cables in Hawaii. We'll navigate to our fiber optic shapefile and load that in. We'll set a minimum distance and a tolerance that we want to maintain around these cables. We'll also set the depth multiplier to 2 times the water depth so that that proximity is respected. And we will leave it as a logistic curve weighting algorithm. In addition, we will disable the constraint within the distance of the endpoint of around 10,000 meters so that it makes it easier to start. Rules can be edited from the list by double-clicking the rule or by selecting the rule and hitting Edit Rule. In addition, you have the option to remove rules outside of the ones that are automatically added. We also have the ability to set different weightings for the rule to set a preference for cost versus risk, or make certain rules higher priority for the algorithm to maintain low risk for. In this case, we can just say that the slope rules are the most important to not violate for this example case. Now we're ready for our first full ARG run. We will click Run under the main trunk panel so that it runs our trunk seed path. With all rules enabled, the algorithm explores more cells to meet constraints like slope, proximity, and alter course spacing. Once completed, the results window shows which rules caused the most violations, which can be helpful when refining our parameters. These results can always be brought back up before the next run is done by selecting Display Results again. Once satisfied, we click Export to send the generated route back into MakaiPlan. This will create a full RPL and also the Makai path file. This will also handle details like generating the profile over the whole route and assigning cable types. This concludes the setup and initial run of Makai's Automatic Route Generator. These steps form the foundation for all ARG projects. Be sure to check out our other videos for deeper dives into advanced features like algorithm weightings, branching networks, area-specific rule sets, and via points and via areas.